This is problem number 10 from section 2.3. In this problem it says, in a certain city on the 90th day, March 30 of 2008, the sun rose at 6:30 a.m. And on the 130th day, May 9, the sun rose at 5:30 a.m. Use a linear function to estimate the days when the sun rose between 5:45 a.m. and 6 a.m. Do not consider days after May 9. So the first thing we want to do is we want to write out our coordinates to actually make our function. But I want to take 6:30 a.m. and 5:30 a.m. and I want to break them down into something that's easier for me to figure out. So I'm going to do the minutes. Basically, I'm going to take 6:30 a.m. I'm going to use the minutes after midnight. So 6:30 a.m. That's we can do 6:30 a.m. converts to 6 times 60. We'll go 6 times 60 plus 30. So 6 times 60 is 360. Yeah, 6 times 60 is 360 plus 30 is 390. So 390 minutes. And we'll call it after midnight. Or we'll say 12 a.m. Okay. And then we're going to say that 5:30 a.m. converts to 5 times 60 plus 30, which is 330 minutes after 12 a.m. Okay, now that we have those written out, I think this makes the problem a lot easier to work with, because our coordinates then, on the first day, which is the 90th day, we have a coordinate that's 90, comma, because these are the days, so days obviously going to be the x values, 390 minutes. The other coordinate is going to be 130, and that will be 330 minutes. Okay, and I'm going to label this as days and minutes at the top. Days, minutes. So let's pull out our finding slope and our point slope formulas. And we're going to label this x1, y1, x2, y2. And we're going to say m equals y2, which is 330, minus 390 over 130 minus 90, which will give you negative 60 over 130 minus 90 is 40, which will give you negative, let's see, if we divide them both by 20, we get negative 3 over 2. If you want to use the decimal, I'm fine here because that works out perfectly. We'll say negative 1.5. And that's a negative 1.5. This is minutes per day. So we're losing 1.5 minutes per day of sunlight. We're actually not losing it, we're gaining it, right? Because it says minus 1.5 minutes per day. So, and we're going from having the sun rise at 6:30 to 5:30. So although it says minus 1.5, just realize that that means that you're actually gaining daylight in that situation. All right, so now we're going to say y minus y1, which is 390. So y minus 390 equals negative 1.5 x minus 90. Okay, now we're going to distribute this, so it's y minus 390 equals negative 1.5 x negative 1.5, oops, sorry, negative 1.5 times negative 90 is 135, so plus 135. Let's add 390 over and we get y equals negative 1.5 x plus 390 and 135, 525. All right, this is our equation that we're going to use. So I'm just going to kind of underline it because now they want us to figure out, it says this model predicts that the sun rose between 5:45 a.m. and 6 a.m. from this day to this day. So I want to solve an equation between 5:45 and 6 a.m. And this function's got to be in the middle. Well, 5:45, let's convert that. 5:45 would be 15 minutes longer than 5:30, right? So 5:45 converts to 345 minutes. And 6 converts to another 15 minutes, so it's 360 minutes. So we want to look to see 345 needs to be well, it needs to be the smaller number, so it needs to be less than or equal to x, which is less than or equal to, not x, less than or equal to, I'll cross it out, 345 needs to be less than or equal to negative 1.5x, right, our formula here, plus 525, which needs to be less than or equal to 360. Okay, so let's go ahead and solve that. So we're going to subtract 525, so minus 525 from each thing. 345 minus 525 is negative 180. Less than or equal to negative 1.5x. Less than or equal to 360 minus 525. Negative 165. Now we're going to divide by negative 1.5. And negative 180. So divide this one by negative 1.5. And negative 180 divided by negative 1.5. So I get 120 here. Now when I divide by a negative, remember I flipped the inequality sign. So that's now greater than or equal to x, which is greater than or equal to, when I divide those, I get 110. So that's telling me my days have to be from 110, as the smallest, to 120. I like to usually rewrite these, and I'll do that. 110, make sure the less than is pointed toward it. X, make sure the less than on this side is pointed toward it. 120. So between 110 and 120, that's our solution. So when it says this model predicts that the sun rose between 5:45 a.m. and 6 a.m. from day 110 to day 120. And we could write that in interval notation by saying 110, 120 with brackets on it on each side.